Okay, so for the next question, we have question 30. And I believe this is quite a simple question because, as you know, you have all these three processes. If you remember, we talked about that. What's it called? 抓什么奸细，抓贩毒团集团啊，那个故事了哈。That story. So if we said that you first have to capture all the people, that's called ultrafiltration, and then you let go of the good people. So we reabsorb them into the village, right, into the bloodstream. Then finally, we catch all the big guys behind the scene. We catch all of them and we secrete them again. So we secrete the bad stuff out again. So that is the three processes over here. A, B, C, you have three locations. As I mentioned before, whenever you see unknown, 看到 unknown, 给名字, three location, three names, and each of the location has something happening. There is a process name for each of them. Then explain a little bit about the process, who and what pass through what thing. I think that's quite easy to score. Okay, so let's start from the first one. We have A. By the way, try to write maybe somewhere up here because I'm a bit afraid of the space constraint. So first of all, A is Bowman's capsule. Remember, yeah, Bowman's capsule is the one that captures, okay, the whatever blood vessel thingy, that is glomerulus, okay, that is glomerulus. So Bowman's capsule, 包 for 包，它会包着 glomerulus. It was supposed to cover the glomerulus. Cool. And what is the process? This is ultrafiltration. So you can say ultrafiltration occurs. Ultrafiltration occurs. And here you go. You can now then talk about the details of the process. And I think if you remember, this is quite straightforward. Basically, due to the high hydrostatic pressure, HHP, it forces everything else to come out except three things. So high hydrostatic pressure forces substances in blood to diffuse across glomerulus. So you come out of glomerulus into Bowman's capsule. Okay, 被包起来. And don't forget, yes, as always, remember, why do we call it filtration? Because something is filtered. So there is going to be three particular components that cannot pass through. And remember, these three names must be written because this is always 1 mark for you. So except these three guys, erythrocyte, platelet, and plasma protein. Erythrocyte, platelet, and plasma protein. So that is the first one. You see, by literally giving the name of the place, the name of the process, and a little bit of explanation, you get the point. Okay. Yeah, this is not even everything. This is not even a full answer. This is just a few sentences from your notes. Right. So moving on, we go to B. It should be also quite similar. B is the curvy one in front of the nephron. So we call it proximal convoluted tubule. 前面的卷卷的 tubule. Proximal convoluted tubule. The one in front, which is, what's convoluted called? Entangled, whatever, mass, yeah, curly. So with that, we have the process, we have the name. We also can add the process. What happened here? Reabsorption. Reabsorption occurs here. And yeah, just give a little bit of explanation. What is actually reabsorption? And again, if you remember, there's quite a few items, your salt, your water, and your most important thing, your two bodies. All of them have to be reabsorbed. So all glucose and amino acid are gonna be reabsorbed into your blood capillary. And yes, don't forget to also mention the type of transport. In this case, this is active transport. Okay, active transport. While for, okay, you can talk about others. You have sodium chloride, whatever. So in this case, let's just give one more example. For water, water is reabsorbed. Same thing, it is also into the blood capillaries. But of course, it's not by active transport. Water always use osmosis. Okay, water always use osmosis. So that's the first, second one. Right, and the last one also quite simple. Just talk about, again, what they say, what process happens here, and what actually passed through. Right, so say, as you can see here, say is the one at the back. It is also entangled, curly and all, but it is at the back. So 后面的卷卷的 distal convoluted tubule. Distal convoluted tubule. And as usual, what process happened here? Secretion. Secretion. And yeah, as usual, talk about what happened, what actually happened, what stuff actually passed through, right? So we have, let's say, urea. Urea is thrown out of your body into the urine, into distal convoluted tubule by active transport. Then we also have, let's say, you can also talk about some toxin, some drugs or whatever. They also diffuse or secreted. Actually, you can use the word diffuse into C, typically by simple diffusion. Okay, yes, your body aren't built. Okay, your body aren't built for all those random stuff to to have a carrier protein to do active transport. No, they're just gonna do simple diffusion because they don't have a specialized carrier protein that is designed for them. They are literally drugs that you are not supposed to eat. Okay, that's it. Yep. So yeah, that is it for this part. I think should be quite simple. Again, just make sure you remember the drawing, the name of the site of transport, then what happened there, who passed through how. Okay, that's it. Okay, so thank you very much. See you in the next question. What? I can't pause it. What happened? Oops. What's happening? Uh,